Yo, what's up, guys? Okay, today we're going to solve a hard problem. That's a minimum score after removals on the tree. Wow, this maybe take a lot of time. The read the statement together. There's an undirected kinetic tree. A tree, remember a tree with n nodes. Okay, you are given a zero index integer's arrays nodes of length n. So the values of each node. Okay. You are also given a 2D integer array x, or it represents an F between nodes in trees. Okay, a tree, yeah. We move to distinct, distinct, distinct edges of the tree to form three kinetic. Okay, for pair of remove edge. The following step are the following. Get the sum of all the values of the nodes for each of the three components respectively. Okay, and the difference between the largest sum and the smallest one is the score. All right, it's really easy to understand. Return the minimum score. Oh, so really hard. Yeah, man. Let me just a minute to think about this. The first example, got this tree, and the minimum one answers in 9. Uh, First component, no, it's 1, 3, 4, 3, 4. Okay, and okay, I see. This saw is like 10. It's 1 at 10, and 1 is become 9. Let's see. Okay, just check out the constraints. Oh, 1000. That's mean we could do something like 2 4. That means to select 2x to remove. Let me draw here, and we could think together. So for example, we got a tree, a long tree like this. And this is just for example, okay? Uh, for example, we're gonna cut an add like this, and we got this, this subtree, and we may cut some add like this, and we got this subtree. In the case, it belong to two different branch. Um, we could get the saw by do the DFF and get the saw of the subtree, and the saw of the remaining, the remaining trees. It's just the total saw. We saw with the sub A and saw with sub tree 2, and we got the remaining. Let's see the sub tree 3. This easy. But in the case, when we cut an ad like this, and maybe we cut a parent branch, and actually the tree must be this, and that's been to solve the subtree and ignore solve this subtree, right? I mean, the solve the tree 2 is like the solve. Actually, the solve subtree because okay. I mean, yeah, actually that's sh store to the node we select. Okay, And that's okay. The first case, it went to branch it from a different branch, so it's not related anything together. Did not each relate anything to each other, so we could get the sum of the subtree, the solve sum of subtree. But if in the case an edge that is parent in the same branch, it must be ignore the ignore the subtree subtree sum. But check another case. There's two cases, right? Mm. For example, we gonna cut like this, and this uh, uh, in that case, the remaining is like uh, so I mean t saw the subtree, the total saw the subtree h. For example, you cut it, and the remaining, we can do this because actually we could do this. Because this one saw this one equal to this reciprocal, so it's still the same. Keep this formula, the final formula. So I think this is all that calculate on the subtree. Then an escape. Let me draw some another tree. Uh, I just wonder the case. But I think there's only two cases. That is parent and non-parent. For example, this case, a very long tree, and we cut this branch and cut this branch. It's not, it's not sharing the same parent. So I mean, it's sharing. It's like it's not a parent of the other. So just get this subtree and this subtree individually. But in the case, this case is still the same, right? But in this case, it's not the same anymore. All right. And the problem turns out we need to figure out if a node is the parent of another node. How could we could do this? Um, yeah, actually we could do this using early tourists. Early tour. Uh, we keep the DF time. Example, just wait a minute. For example, when to cut this ad, last mean we cut the ad from this node, maybe the ads directly from this node. Um, yeah, for example, cut the ads. That means we're gonna cut the node, this node, and this node ads, edge, and we could determine if this parent by check the travel times. For example, this you travel this by the first time you travel this E1, and then this 2, and then 3 use the DFF 4, the 5, and after that done you done. This is the end, the travel ending time. To this, and you're gonna go to this, and it might be like 6, 7, and still 7. Go back to here, and it's be like 8, 9, and the out time is 9. The out time is 9. The out time is 9. Come back, this the out time is 9 too, and the out time is 9. The time is 9. That's totally 9 nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9 nodes. You got the enter time. You got the exit time. So based on this, you can determine if it is parent of another node. For example, the 8 and 9 is just a subsegment of this one. A subsegment. For example, this is 2 and 9. 2, 9 is this. 2, 9. And this is 3, 9. This is, so it just exactly is the subsegment of this one. So it must be a children. So we're gonna code it right now because we could use to follow and fast calculate the the root. So we're gonna do something like the root. Wait a minute. Pilot. The root. Sorry is the vector in the subtree store. Okay, that is another thing we need to store like a vector of like uh, in time and out time. I don't know if the ins is really exists or not, but it's not the running, so maybe we're gonna write an dbf function here. Um, travel from the first of all we need to build the the addressing magic. This is uh, from the edge, the s actually is the s. We're gonna do adjacent with size and size plus one the node. Actually, if you want to do so, down here, style and adjacent u x I with one and baseline and I two one. Sorry, just it is undirected graph, so just put it to sign. Okay, that is uh, and we want to write a dbag function here, even the the adjacency magic and uh, the node, the root, the current node, and maybe it's parent in order to prevent double calculation. Okay, for on the try not if we different we doesn't travel to the parent, gonna do dbag to v and the parent is now is u um u and p. Yeah, and we need to calculate the sub the subtree saw of the node u is actually, oh my god, forgot the nums. I think we're gonna pass the num here to nums. It is that is nums u, and after we travel to the children, we're gonna already got the subtree saw. So all we do is like u saw with this value subtree saw v got on it because it's recursion. We already traveled to the v on the subtree v, then we got solve it. Okay, that's it. That's it. Okay, all right. Now we got the subtree, but also we need to timer zero. This timer. So we need to um, uh, the timer says the in time of use by timer and the out time of use is the timer. That's we create a early tour. This actually you could early tour on tree. You could sit just this like um, on the internet early tour techniques. For representing trees. The trees is viewed as a directed graph, okay, that contain two direct x for each edge in the tree. The tree can then be represented as a like circuit. Um, Parallel computation. Oh, really? Which okay. This is actually just the definition of this, but you already know that based on the in time and the out time, you could understand the order of the tree. For example, you got one, two, then six, then six. That means you can see two six here. It's the in time, the end time, and based on it, you can determine if a range, for example, the range from two to two here contains six. That means 2 is parent of 6, or you can check the 1 here. So you can know that 1 is like parent of not 2 and 6. That is very simple. The edge of it. Okay, you got the outcome here, and we also need to debug here. Nums for the root, maybe I gonna use whatever. You can use whatever root. I use 0 parents, maybe what -1 because it doesn't it have the parent, the tree, the on tree have its parent. No, I think it's a root, so it doesn't have parents. That's it. For example, you take this 0 as root, so just revert the tree. Okay, and now the 5 answers. You need to get the tracing to, yeah. Actually you can write it right now here. Answers I want the mass minimum. Minimum, so I'd love to use a very large value like this. As an initial value, and now we will gonna select to edge. That means we select to edge. Based on the edge, you gonna know, you gonna know the order of the tree. But now let me check out the implementation here for easier understanding. You got the edge. Okay. How do we know? Like, for example, choose node 2 that's not doesn't have the direct. Mm. All right. Another. Uh, just to we try each pair every pair of edge. um, we're gonna write the u. We could check if a parent is parent here. Is parent u and v. Like get parent. No, if parent is parent of v. Return if the intime of u is less than intime of v, and outtime of v is less than or equal to outtime of u. That is, we got the edge. We're gonna determine if that edge belongs to what. For example, this edge. Actually, we gonna do it. Consider it at this node. Maybe this node. The most simple way is don't do like me. Like you can do on it directly on the edge instead of instead of my way. I just consider this at the node. Okay, but whatever is still solve the problem. If this parent of h I0 h I1, I'd love to swap it. Oh no, wherever I'm gonna use u is 0 and u like h e1 is the parent, u like h change 0 if not parent, so 0 and h choose 1. I'm gonna this must be choose 1. Okay, you got the h u and delete h u and v so check if is parent u is parent of v or what. If not, if first if is parent, it's not parent, and if is parent, if V is parent of U, and the last case is no parent, different branch. Um, so the access the curve is like the, you know, you got um, S1 and the total, yeah, the total here is exactly the subtree saw of the root, right? U1, maybe U2, one, swap, U1, U2. Turn if not carry, two, gonna swap it, U2. It's very simple. And now S1, S2, and S3. Okay. Um, or direct H U1 and that is if U is the parent. No. It's like we delete this add. We're gonna check this add is that. Um, but I think it's okay. It's very okay. You, for example, delete this branch. So you must check the try. Okay, the try please. If this try is with this is not the same, so we're gonna you see the S1 is like S1 sub G1 is um, you know the sub G source of the V maybe U2, and N2 is like sub G source of the V2. This in this case is the forgot in this case please, in this case um, this is the U1, this is U2, this is like uh, V1, this is V2, and you see V2 and U2 is not belong to the same subtree, and got a subtree of V1 and subtree of V2, and the last is like the total star V1 star V2. It's always like that, so I will put it there. Uh, and in the case it cuts something like this. This is U1, this is U2, and maybe okay, this is U1, this is U2, and maybe this is V1 and this is V2. I gonna check uh, this subtree and this sub. Maybe this is okay. Okay, I will take a check V1 or V2. This is okay. It doesn't change anything. It didn't change anything. I see this one and this one. No, this is change anything. So just keep it. And okay, let's in this case, for example, in this case, I'm gonna calculate the subtree of the children that's the subtree solve of V2. Is that? And that's V. No, V1, please, V1. Because the for example, you got it, and you got this H. We're gonna cut this. I'll say V2. Sorry. But in this case, it's still V2. Okay, the subtree of the V2, and the here's the N2. Actually, the subtree sort of the of it. That is the U2, but we need to remove the the subtree one out of it. Oh, so we got it. And this got this the edge. You cut this, you got this. Sorry, maybe you could understand. What the? Why? Why the record is so stupid, man? God, such a waste of time. But I don't have time to record it again. Really sorry, guy. Ah, God. Okay, just keep continue. I will explain this again. Uh, I don't know how to explain it, but it's like gonna use a derivative to calculate the tree, the star of every subtree, okay? And use the and we need to determine if we want to delete this add. For example, we want to delete some edge, add, this add and this add. We need to check if this add is like the containing this add or what? I mean this subtree. Check this subtree is containing the subtree after cut by checking this node and this node is this is a successor of this one or not, um, because it will affect the answers if you cut something like this that have the parent relationship. um, so the solve the children is still the subtree solve, but the solve the parent node is exclude the subtree one. Then we need to determine if this is the parent of this by using array tool. Array tools is consider uh, construct to array in and out to determine if when we travel, use the web travel to a node and when we out this node. And based on that, you can see this is the example of array tool. This is 19 and is the parent of on the node that have in and out in the subsegment of this. For example, this is 4, 5, and it actually the subsegment of this one. This is 3, and this is what? This is 9. Okay, is the subsegment. So it's a child. So I'm gonna derive calculate sub 3, calculate the in, the out, and check its parent using this condition. And then if in the cut, if, oh, we can do this better. In the cut, if it's belong to a subtree, that's its parent, the two edge. Okay, consider an edge because is represented by this node. After cause the children nodes will be the roots of the new tree. Okay, and for example, this the children node is the later new tree, and we'll check that this is already the parent of this. So we're gonna take the solve the children and take the substore, the solve the parent and exclude the children at the same as this. Oh, that is we got two subtree. We got this one, and in the case it's belong to different root like this. For example, you cut this edge and maybe this edge. So the solve subtree is it not affect each other. So just get it, set it out, and the total one is the total tree. I subtract the subtree one and subtree two. That's it. And we got the three, the three. So just get the maximum answers and the mean answers of mass of x1 and 2 and 3 minus mean of x1 and 2 and 3. Oh, that's it. Okay, that is the solution today. Oh no, I forgot to initialize. It's gonna got an what? An error. We need to in design and out design and step console design into. Submit. Oh my god. Really? Ready? Check it out. You think so? Because I need to go to work. Nice thing. This one and 07. This one is actually belong to different tree, and the saw of this one is the stick, the no stick. This cut this because it's some 7 in 1. Let's see. Yeah. Uh, 15. That's right. And the remaining one. 0. God. What? 0 for real? But my okay, it's 0, so it might be solved. This one, got 3. But why is it 10? What? Why it? Sorry. It's 2, but why it 10 here? Oh my God, can't believe it. Sorry. Sorry. Where? Is this? Oh no. Oh my God. Sorry. No. No. Sorry. Really sorry. A silly mistake. The whole algorithms is right, but my implementation is suck. set it please, and you got it. But